Hello everyone, this is Dr. Lennon, and I just want to give you a quick walkthrough on this stat activity number one. You can find stat activity number one by clicking on learning modules and then going to step 4 doing, and then it's right here, stat activity number one. And basically here's the instructions. I want you to go to the US Census Bureau, and there's some people estimates. You have to look at some numbers. We're going to be looking at the percentage of senior citizens aged 62 years or older in 2010 compared to 2000. So you're basically going to look for two sets of numbers, and we're going to use StatCrunch to go ahead and do a 2-sample p-test. So it's going to be very similar to what we did in Chapter 8, and it's going to be a little bit of a preview of next chapter. I want you to put your findings in the Word document and also do a screenshot of StatCrunch and include that as well. And then append your file name, save it as your initials .doc or .docx. So that's where you find it on Blackboard. Right now we're going to move over to my stat lab, and we're going to do a similar one. So this is the same sort of thing as the problem you'll be asked to do, just with different numbers. So we have a simple random sample of front seat occupants involved in car crashes. You have 2,934 occupants not wearing seatbelts, of which 35 were killed. And you also have 7,823 occupants wearing seatbelts, and in those accidents, 12 killed. So here we want to use a 0.01 significance level to test the claim that seatbelts are effective in reducing fatalities. So that's going to be significant. The 0.01 tells us whether or not we will reject or fail to reject the null hypothesis. So in Chapter 8, we would always have p equal to a number. Whenever you have two samples, we have the 2,934 sample and the 7,823 sample. Our null hypothesis, H0, will always be P1 equals P2. And then we want to test the claim that seatbelts are effective in reducing fatalities. So in the first one, they're not wearing seatbelts. So they're trying to test the claim that there's more fatalities in those that don't wear seatbelts than those that do. So P1, the proportion of those that are killed in not wearing seatbelts, would be greater than P2, those that wear seatbelts. So it looks like choice D here. P1 equals P2 is the null, and P1 greater than P2 is the alternative. So now we want to identify this test statistic. So to do that, we want to go to my stat lab, and by going to my stat lab, we'll be able to go ahead and find this information. So StatCrunch. So on the left side of my stat lab, click StatCrunch, and then click the StatCrunch website, and it'll bring you into that, and then click Open StatCrunch. I believe there's also a way to get there from whenever you have one of these open, but for our problem, you won't be using necessarily a question. I don't actually see a StatCrunch link here, so you can always get to it by doing the left side. So what we want to do is we want to go to stat, and then we want to go to proportion stat, and now we've got two different samples. So we want to go to 2-sample, and we're doing it with summary. So click with summary, and then we have our two samples. So if we go back to the problem, sample 1 has 2,934, that's the total, and 35 would be the number of successes. So 35 successes out of 2,934 observations. Yeah, and then sample 2 will have 12 successes out of 7,823. So 12, 7,823. And then we have to do our hypotheses. So null is P1 minus P2 equals 0, and here it's a slightly different form. We had P1 minus P2, P1 greater than P2, and if P1 is greater than P2, then that means P1 minus P2 has to be positive or bigger than 0. And then all we have to do is click compute. Okay, so these are our values. So our z-stat is right here, 7.2803. So we can come back over here and do 7.28. It just says rounded 2 decimal places. And then our p-value is very, very small, 0.001, less than that it says. So since it says to round to 3 decimal places, we can probably just round it to 0 and be okay. So because we have such a small p-value, less than 0.01, that means that that's an unlikely event, so we reject the null hypothesis. So because the p-value is less than the significance level, we reject the null hypothesis. So there is sufficient evidence to support the alternative hypothesis. In the other scenario, if it's greater than, then that means it's a normal event and you wouldn't have sufficient evidence to reject the null hypothesis. So you would fail to reject if you got a p-value bigger than 0.01. Yep, so that's how you do the problem, and when you're loading this into a Word document, you can actually save this, right-click and just save it, and you can go ahead and copy it into your Word document. Another way you could do it if you don't like that method, you can always hit the print screen key. So on my keyboard, it's right in between the F keys and delete. So if I hit print screen, what that does is it takes a copy of my entire screen, and I can go ahead and, since it says screenshot added down here, I can even go ahead and just open another program, like say Microsoft Paint, if I wanted to. And if I open that, I can actually just right click, or maybe I have to do it this way. I can just click the paste key up here, and it'll paste a copy of my entire screen. And if I really want to, I can just crop out the window that I'm interested in and delete everything else. So I can cut that, I can do a whole new screen, and then just again paste what I cropped. And then I just have this StatCrunch analysis that tells me everything that I performed on my calculation. So you will have to do the same thing for stat activity number 1. You'll just have different numbers. You'll have a different count 1, total 1, and a different count 2, total 2. And you'll be getting those on Blackboard when you go to this link right here. This link tells you the data, and you just need to navigate through the table and find the senior citizens age 62 and older in 2010 compared to 2000. So we're calculating that percentage. Okay, well, I hope this has been helpful, and good luck with stat activity number 1.